Hi friends, let us discuss another algorithms called Horspool algorithms under space-time and trade-off. As we have studied that space-time trade-off means what? We are providing or using extra space in order to decrease the complexity. Right? Under this, we are going to learn now Horspool algorithms. Remember that Horspool algorithm is based on input enhancement. What is input enhancement? Is to use another structures, right, to simplify, to restructure our input such a way that it will take lesser amount of time to perform the task. If you see that normal pattern matching algorithms, we are comparing from left to right. Right? If character is matching or not matching, accordingly we will shift pattern towards right. But in Horspool algorithms, we are going to compare the right side of the pattern. If pattern is Delhi, D-E-L-H-I, then we are going to start comparing from I, last letter of the pattern. Right? We have different case to discuss. We will discuss one by one. Pre-process the problem's input in whole or part and store additional informations obtained to accelerate the problem solving afterwards. Who invented this? Who has suggested this algorithm is Horspool. Horspool algorithm is given by R. Horspool, that is after Boyer-Moray pattern matching algorithms. Now, interesting part is these Horspool algorithms works based on the shift table. Right? Normal pattern matching, linear pattern matching, we are knowing that one by one, character by character, we are going to shift towards right. But Horspool algorithms is going to perform the task based on shift table. It means before you are starting our pattern matching, we are going to create shift table based on the given pattern and number of characters present in the pattern. In that case, algorithm scan the pattern from right to left, starting with the last character of the pattern. The corresponding pairs of characters in the pattern and the given text are compared. If a mismatch is encountered, the pattern is shifted towards right, based on the length of the shift, which is determined at the beginning. Let us discuss, there are different cases for shifting the pattern based on shift table. Point to be noted, if first character itself is not matching with the pattern, first character of the text is not matching with the pattern, and that particular text character is not present in anywhere in the pattern, who will tell that pattern is, that particular text or character is present in anywhere in the pattern or not? Shift table will tell. So if that particular character of the text is not present in anywhere in the pattern, then that complete pattern we are going to shift by pattern length, because shifting by one character is just a waste of time comparing again and again. So we are going to shift whole together towards right. Right, that is what your first case is. Case 2, if there are occurrence of the character, right, in the pattern, but it is not the last one there, then shift is made in such a way that it should be align the rightmost occurrence of the character in the pattern with the, say, in the text. I will give you the example. Okay. Case 3, if character happens to be the last character in the pattern, but there are no character among its other m-1 characters, then shift is made to be entire length of the pattern. So case 3 is little bit correlated with case 1 and very similar. Similarly, case 4 is going to be similar to case 2. If character happens to be the last character in the pattern and there are other characters among its first m-1 characters, the shift is made in such a way that the rightmost character's occurrence of the C among the first m-1 character in the pattern should be aligned with the text C. Now, remember that these cases you have read, but maybe will be having problem with respect to implementations. So let us see that. First, how to make this shift table. As I said you that first thing is to make the shift table. For every character C, the shift value can be computed as flow, right? T of C, text of C, right? The pattern length M, if C is not among the first m-1 character, then just you are writing that T of C is equal to that pattern length M. If C is not among the first m-1 character. Otherwise, T of C is equal to the distance from the rightmost C among the first m-1 character, rightmost C among the first m-1 character of the pattern to its last character. What it means? Say here we have pattern J is equal to 0 to m-2, table of P of J is equal to m-1 minus J. See, as per example, it is there in your textbook. Say we have a barber. What is position? 0, 1, 2, 3, 4, 5. Okay, so total length is 6. Length of the pattern is 6. Now let us see that. If you are talking about this 0th, what will be the shift values, right? What will be the shift values for this B? So rightmost B, we have one B, we have another B. So we will go and discuss with respect to this rightmost. So let us see that. Here J is 3, table of P of J is B, right? Pattern of 3. So this is the pattern friend, right? And B is a character. So pattern of J, pattern of 3. What is pattern of 3? Is B. So shift table says that T of B is equal to m-1. What is M? M is length. M is 6 minus 1 minus J. What is the value of J? J is 3. So 6 minus 1 minus 3 is 2. So shift will be 2 times. Shift will be 2 times. Means 2 times you are going to shift towards right when, say here is a pattern B. In text we have B, but B and R both are not same. I will give you the example. Then we will see that how many shift you are going to do it towards right, such a way that B will come aligned to that text. Similarly, if you wanted to check with A, do you have how many A's? Only one A. So there is no question of leftmost or rightmost, only one A. So if you are going to write T of A is equal to 6 minus 1 minus, what is position of J? 1. So 6 minus 1 minus 1. Shift table of A will be 4. So 4 times you are going to shift towards right. Look, here is R, right? If you are going to perform the T of R, right? So 1 is 6 minus 5 minus 1. It becomes 0, right? If it is not, then how many times you are going to shift towards right? Look, 1, 2, 3 times. So it is 6 minus 2 minus 1 is 3. If you see that E, how many times it required shifting? Only 1 time. So let us see that one by one. Just I said you that how to compute these shift values at the beginning. So we are going to shift values, we are going to perform based on this formula m-1 minus j. Remember that j is position of pattern characters from left to right. If character is not present, now see how many different characters we have. We have A, B, R, E. A, B, R, E. Only 4 characters is there in the bar, but different characters, not repeated I am talking about. Rest of the characters from A to Z can be anything, like remaining 22 characters can be present in the text, right? Then what will be the shifting values for those characters? Shifting values will be the equal length of the pattern. If that particular character is present, we know that here we don't have Z and first letter is Z. Z and R you are going to compare. Z is not there in this. No meaning of shifting by one character at a time. We can shift complete pattern towards right. Let us see that example. Say here we have text, right? We have some different values we are having it here, right? And say here we have X and we have different characters here. Okay. Now here we are going to write, say it is barber. Now you can see that we are going to compare this and this. Is it same? No, it is not same. If it is not same, do you have any X present in this? No. So what I said, if that particular text is present in this, we'll be having shift values based on the formula. If that particular character of the text is not present anywhere in the pattern, that shift values will be, right, equal to length of the pattern. So this complete patterns we are going to shift towards right. So maybe later on, maybe these characters may be going to match with this or not, but we are going to shift towards right complete length of the pattern as discussed in the case 1, as we discussed in the case 1. So this is a case of case 1, right? Say a different case and see that how you are going to understand. Say you have different characters in present here, all right, and here we have, say, R. Here we have BAR, BER. Yes. And say here is in pattern, in a text we have B and pattern we have R. Text we have B, pattern we have R. Now look, is B and R is same? No, B and R is not same. Then do you have this B, any B is present in this pattern? Yes. What is the positions? From right hand side, it is B, 1 shift, 2 shift. 2 shift is needed, right? If you do the 2 shift, how it looks like? It is looks like BER, BAR. See that B and B is matching now. So again, we will go and compare from here, whether it's matching or not matching. But shifting is needed here, 2 characters towards right hand side. So B will be, B of text will be aligned with B of pattern. Not like this shifting complete characters, no. If pattern is that particular text of the, character of the text is present in anywhere in the pattern, we are going to use the shift table and shift based on the scenarios. Maybe different case will be there, case 3, where we have different set of characters, right? And say here we have R and here we have, say it is X, and you are going to compare BAR, BER. Is this R and R is same? Yes. Is this X and E is same? No. If it is not same, then there is no meaning of checking it because the X is not present in this pattern. If that is the case, again you are going to shift complete because we have to do the alignment if that particular character X is present in the pattern. But in this particular case, this X is not there anywhere in the pattern. In that case, shift values of this pattern is going to be 6 character. Okay, so you are shifting towards right, like this. Clear? This is same, this is not same. So hence we have shifted complete character towards right hand side. Okay. Similarly, we have case 4 when it is very much related with case 2, right? Required length of the pattern we are going to shift towards right. So let us see that standard examples Say in all the cases we can discuss here. Text we have Jim. This underscore is also a character. Show me in barber shop. Now, let us see that we are going to compare B-A-R-B-E-R, barber. Right? Look, character 1, 2, 3, 4, 5, 6. We are going to compare A and R. Is A and R is same? No, it is not same. What will happen? We are going to check whether this A is present in this pattern. Yes. Where is that? It is here. 0, 1, 2, 3, 4, 5. What will be the shift values of A? Shift values of A will be, as we computed earlier, T of A is equal to M. What is length of the pattern? 6. Minus 1 minus. What is the J value position? 1. It is 4 times. So 4 times we are going to shift towards right. We will do the shifting 4 times. What will happen? We can get a line like this. We can get a line like this. See here. 1 shift, 2 shift, 3 shift, 4 shift. So 4 shifts we have done it. To bring this A align with text. So this is the part text and here is pattern what we are looking for. Look. Now in next iterations, this is the first we have done it. It's not matching. You are shifting required length of the pattern. Required length of the pattern means what? You are using the shift table. Now you can see here. We are comparing E and R. Whether E and R is same? No, it is not same. Do you have any E present in this? Yes. Then we are going to shift accordingly. So how it looks like? It is like this. One shift. E and E is aligned. But now you are going to compare this and this. Whether E and underscore is same? No. Do you have underscore present in this barber? No. What I said you, if any character of the text is not present in the pattern, their shift value is going to be the length of the pattern. So 6 times you are going to shift towards right. So you are shifting towards right. So how it is? B-A-R-B-E-R. So 1, 2, 3, 4, 5, 6 here. R and R. Is it matching? Yes. A and E. Is it matching? No, it is not matching. It is a case of fourth case. Case 1, 2, 3, 4. What happened here? A and R are matching. A and E is not matching. But A is present in this? Yes. If A is present in this, what will the shift value? Just now computed, it is 4. So 4 times we are going to shift towards right. So if you are shifting towards right, how it looks like? It is going to be bar. After shifting, A and A is aligned. Now we are going to compare. Is this R and R both are same? Yes. E and E is same? Yes. B and B is same? Yes. This R and R is same? Yes. A and A is same? Yes. B and B is same? Yes. It means barber is present in given text. Barber is present in the given text. But what is the position of that? Remember that when you are going to find out the positions, it is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So what is position? Started here is 14. Right? So we are comparing from here, right? So either you can do that 19 minus 6 plus 1 is your positions. 19 is your last character of the text comparing with the rightmost character of the pattern. So 19 minus 6 length of the pattern plus 1. 19 minus 6 is 13 plus 1 is 14th. Or while you are decreasing these values, while you are comparing it, then you print the last value of k. So that value of k, where we are comparing the last position of the elements, is a pattern found at the position 14th. Based on the index, based on the real life counting, plus 1, index plus 1. Let us see that what are the things we have done it in algorithms. First we are going to compute shift table, that we have already shown the formula. So first we have to complete this shift table. Then I we have initialized with m minus 1. Why? Because I is a pointer of pattern. Remember that I is a pointer of pattern, right? So in that case you can see from where you started I started from the 5th. And what is 5th? 5th is nothing but size of pattern minus 1. So size of pattern was 6. 6 minus 1 is 5. So I we have initialized with 5. So here I is 5. While I less than equal to n minus 1, what is n? N is a size of text. N is a size of text. Do it. K is equal to 0, initialization. K less than m minus 1. K is another pointer that is based on that pattern size. So m minus 1. And pattern of m minus 1 minus k. Remember that in first time. What is the value of k? K is 0. M minus 1, 6 minus 1. Right? Is total is 5. Right hand side, I is m minus 1. What is I? I is m minus 1. Right? So 6 minus 1. Minus, what is the value of k at the beginning? 0. So here also getting 5. It means we are comparing at the beginning 5th position of the text with 5th position of the pattern. 5th position of the text we are going to compare with the 5th position of the pattern. Right? Similar way, what happened? If it is true, both are equal, then k will increase. A moment k will increase, what will happen? K is 1, it means what? We are subtracting more. Means 5 minus 1 becomes 4 and here also becomes 4. Means 4th position element you are going to compare. If k increases, then 3rd position element you are going to compare. And when it will happen? When both the condition is true. When character by character is matching of the pattern with the text, and this condition k less than m minus 1, both are true, then we can do k is equal to k plus 1. At last, what will happen? This condition is going to terminate. When we are going to terminate? When k is not less than m minus 1. Not less than equal to m minus 1 means what? After final comparisons, when element is, pattern is found successfully, then k will be 6. When k is equal to 6 is what? Length of the pattern, then you can say that return these values. And what I said you friend, return these values is I minus m plus 1. 19 minus 6 plus 1. So 19 minus 6, 13 plus 1 is 14. 14th place we have searched this element is pattern is present. That particular pattern is present, a string is present. Right? Otherwise, if this is not, then you are going to use the shift table. If this is not true, then and this condition is failed, then I am going to use I is equal to I plus table of T of I. And what is T of I, friend? Shifting values of that character. Right? Return once if we are not able to find any pattern in the given text, then finally we are going to return minus 1. In that case, we can say that pattern is not present. Say another example. Say we have and we are going to search uncle. So what is happening? It is simple example. What is happening here? U and A. Is it matching? Not matching. So what is our concept is there any U is present in this? Yes. And what is the shifting values? See here 0, 1, 2, 3, 4. It means our length is 5. So m minus 1, 5 minus 1. What is the value of j here? 0. Is 5 minus 1 is 4. 4 time you are going to shift towards right. So one time we will shift, E will come here. Next L, C. So finally we will get U N C L E. And we can see that this character is matching. Hence element is found. Where it is found? 0, 1, 2, 3, 4, 5, 6, 7, 8. 8 minus 5, 8 minus 5 plus 1. So it is fourth position. So fourth is the positions where we can search the element successfully, search the pattern successfully. So only one, how many iterations we have done it? Only one shift. Only one shift. And how many comparisons we have done? 5 for successful comparisons, 1 for unsuccessful. Total is 7 comparisons we have done for this searching anchor. Right? Otherwise, if you are not applying Horspool algorithms, then how many comparisons is needed? We will start from here. First, we are going to compare U and F. It's not true. Then we will be shifting towards right. U and U is true. So let us see that. If it is normal pattern matching, in this case, as I said you that how many comparison needed? 1 comparison for false case plus 3 plus 2, 5 true case, 6 comparisons we have done. When we are applied Horspool algorithms, while normal comparisons, how many comparisons are going to complete? F and U fail, 1 comparisons. Then you are shifting towards right, normal pattern matching. U and U is same, N and same, C and underscore is not matching, 3 comparisons gone. Then again you are shifting towards right, U and N, 1 comparisons. U and underscore, 1 comparisons. U and U, from here U, N, C, C, L, E, 5 comparisons. How many total comparisons is required in ordinary pattern matching? Or we can say that linear pattern matching, or you can say that sequential pattern matching. So this is based on Horspool. 6 comparisons. Here 4 plus 1, 5 plus 1, 6 plus 5, 11 comparisons. Right? So linear pattern matching, sequential pattern matching in simple text and pattern is taking 11 comparisons to perform the task. While in Horspool is completing with just 6 comparisons. Right? So that is the beauty of Horspool algorithms. It performs the task efficiently, effectively compared to linear pattern matching. Summary: takes lesser amount of time in comparisons with the brute force pattern matching as I have compared it now in front of you, and little complex to compute the shift table. Yes, if your shift table is correct, you can perform the task faster. And there is another algorithm technique called KMP algorithm, is faster than Horspool algorithms. KMP is Knut, Morris and Pratt. There are 3 scientists has given another algorithm technique called KMP algorithms for pattern matching. That is really faster than Horspool. Thank you very much. We'll meet you again.